Okay, welcome to our first online course. Go ahead and get out your homework. The homework from the last class was 9.7a. It was a worksheet. Here's how we'll make this work. We're going to, I'm going to show you the answers. You're going to check your answers, and then you're going to answer question number 1 on the Google Forms, which is how many did you get wrong? So there are the answers. Check them all against your work. Count up how many you missed. Answer question number 1, which is how many you got wrong. Go ahead and pause the video, do that, and once you've answered it, come back to the video. Okay, hopefully you answered question number 1. Let's see the new stuff. So the new stuff is the homework's going to be 9.7b. At the very bottom of Google Forms, the very last thing, we'll see a hyperlink to where the form is or where the homework is. Click on that link. You can print it off if you like. If not, just write down the answers to all the questions, and we'll do the same thing we just did for tomorrow. We'll simply check our answers and then write how many we got wrong. Today's lesson is the finalization of this particular one, 2 parts. Today we're going to be doing the cylinders. We will review the prisms, but the new stuff is on the surface area of the cylinders. So we'll get the second part of that objective, calculating the surface area of a cylinder today. As a quick review, remember surface area. The idea comes from this the mathematical concept of a net. And a net is a two-dimensional pattern. In other words, something that's flat that you can fold into the original three-dimensional shape. That's what's called a net. For a rectangular prism, you'll have 6 parts to it. If you fold those 6 parts, you get back to the original 3D shape. So the formula comes from the fact that there are 6 rectangles. For a triangular prism, there's 5 parts to it, 2 triangles and 3 rectangles. But for both the rectangular and triangular prism, the idea of surface area is you add up the areas of the individual parts of the net, and that is what we call the surface area. Seems a little complicated if we do it this way with the net, and it is. Therefore, we generally tend to use the formulas instead of calculating this using the nets. But you can always calculate the area of the net itself, do each individual part, and you'll still get to the same answer. So last class we learned the formula for surface area of a prism, both rectangular and triangular. For a rectangular prism and for triangular prism, 2 different formulas for surface area. For a rectangular prism, the surface area is the perimeter of the base times the height of the prism plus 2 lengths and widths of the base itself. Here's a quick example. Here's a rectangular prism. I generally tend to use the top and bottom as my base because all the sides of a rectangular prism are rectangles. You can't do this for a triangular prism, but you can for a rectangular one. So if I consider the top to be the base, the formula asks me to do the perimeter of the base. That would be the distance around the top. Let's see. The perimeter around the top will be 3 plus 4 plus 3 plus 4. And that'd be 8 plus 6, which is 14. The height of the prism, or the distance between the 2 bases, I'm using the top and bottom as my base. So the distance would be 10. And then the length and the width of the base, remember I use the top as the base, would be 3 and 4. Do all that math, you get your answer. And remember the units would be squared because we're doing area, surface area. So that's why it's 164 centimeters squared. For a triangular prism, different formula. The bases are triangles this time. It has the same feel to it. You're still doing the perimeter of the base, the triangle, times the distance between the 2 triangles. That's the height of the prism. And the reason why there's not a 2 there or a plus 2 length times width is because it's a triangle. So a triangle is 1/2 base times height. And if we did 2 of them, half plus a half is a whole. That's why it's just plus BH. Quick example. This time the bases are facing us front and back. Therefore, it's not top and bottom. But the formula has the perimeter of the base, which is a triangle. Notice on this triangle, all the sides are 4. It's equilateral. So 4 plus 4 plus 4 is 16. The height of the prism, or the distance between the 2 triangles, is 8. And then plus the base and the height of the triangle. Remember, we look for the little square to find the base and the height. So the square is touching 4, and the height is 5. So 4 times 5. Do that math. And then once again, we get to an answer. And remember, the answer is squared, or the units are squared, because we're doing surface area. So there's a quick review on what we did and what you had last night for homework. On to the new stuff. So the new shape is a cylinder. And we'll get a different formula, but let's take a look at the net first. So let's see, surface area of a cylinder, remember we're try to draw the net. Well, imagine this was a tube instead of a cylinder, so ignore the two circles. And you were to cut straight down from top to bottom the tube and then lay that flat, you'd get a rectangle. Add to that the top and the bottom, which are circles. Well, that shape right there would be the net. Convenient to us because we know the area of a circle, so the area of a circle is pi r squared, and we know the area of a rectangle, length times width. So all we got to do is look at that in relationship to the cylinder it comes from. Well, length times width, the width of that rectangle would be the same as the height. The length of it a little bit hard. That would be the distance around the circle. And remember, we called that circumference. So the length is going to be circumference. The height is going to be the height. And then obviously that's our lateral area. And then to that we'll add our two base areas, which are circles. So let's see if we can write this formula. So surface area of a cylinder will be the lateral area plus two bases. And the lateral area, in this case the rectangle, will be the circumference times the height. Well, I know what circumference is. Circumference is 2 pi r. The length and the width would be 2 pi r. I'm sorry, the length would be 2 pi r. The width would be the height, so that would give us 2 pi r h. Remember, you can always pause this video and replay it a couple times to hear that. Plus two bases. Well, the two bases are two circles, and the area of a circle is pi r squared, so it'd be plus 2 pi r squared. So there's your formula for area, surface area of a cylinder. Okay, cool. Once again, pause the video, rewind it if you have to hear that, if talked a little bit too fast there for you. So let's look at one example. So do this with me, please. You don't need to redraw the cylinder, but please do the math with me. Pause it when you need to pause, rewind when you need to rewind. So the formula for surface area of a cylinder is 2 pi rh plus 2 pi r squared. There's a lot going on there, but really, there's only two variables there, the radius and the height. So the only way I can mess with you is to give you a diameter instead of a radius, but I have to give you, at least on the cylinder, I have to give you the radius and the height. And I did right here. The radius is 3 and the height is 4. So from left to right, just follow the formula, plug in the numbers. 2 times pi, the radius is 3, and the height is 4. Plus 2 pi, and then the radius is 3. Remember that's squared. Now remember, you got to follow the rule of PEMDAS, so we got to do exponents first. 3 squared is 9. But multiplication is commutative, so we can multiply 2 times 3 times 4 before we do pi. And one point I want to make out. Now, clearly we're going to be doing this with a calculator. You can type this in from left to right unless you have a calculator that doesn't do order of operations. All scientific calculators do order of operations. So you can type this in exactly the way it appears into your calculator. But if you were doing it by hand, ouch, if you were doing it, that's painting, that's not real. If you were doing this by hand, let me show you a technique for that. All right, so instead of multiplying 2 times pi, I'm going to multiply 2 times 3 times 4. Multiplication is commutative. I can do it in any order. I'm just choosing not to multiply by pi first. 2 times 3 is 6. 6 times 4 is 24. 3 squared is 9, and 9 times 2, well, that would be 18. So I could turn this whole thing into that, and notice I haven't multiplied by pi yet. In fact, it says add. Well, I can add 24 and 18 pi. 24 and 18 pi would be 42 pi. Notice I haven't messed with pi. When you're doing this by hand, this is a neat trick to keep you from having a decimal right from the very start. If we just simply go from left to right, the top equation right there, we're going to get a decimal after the first calculation, after we square 3. And no one wants to have multiple calculations with decimal by hand if you can avoid that. So here's a way to avoid that until the last step. Now you will have to multiply 42 times pi. And remember, anytime you multiply by pi, we're doing an approximation, 3.14. So we get an approximate answer. So when you multiply 42 times 3.14, you get approximately 132. And once again, it's surface area, so square feet. Cool? You might want to rewind that and play that again just to get a feel for how this is done. And hopefully maybe you beat me to that answer. All right, one more. Let's do this one together. Here's another cylinder. Once again, I have to give you the radius. I have to give you the height. The only way I can mess with you if I give you the diameter. Remember, if I give you the diameter, just cut it in half to get the radius. So our formula says 2 pi rh plus 2 pi r squared. The radius in this case is 2. The height is the height is 3, so we're going to plug those values in. 2 is the radius, 3 is the height. The radius, once again, is 2. Order of operations says do exponents first. So 2 squared is 4. 2 times 2 times 3 is 12. 2 times 2 is 4, times 3 is 12. And 2 times 4 is 8. Going too fast, rewind, pause, take a moment. 12 plus 8, or 8 plus 12 is 20, so we get 20 pi. And that's what we're going to actually convert back to an approximation, because now we're going to multiply by pi by 3.14. Okay, so I'm getting about 65 square feet. Okay. All right. Here's what I want you to do. I want you to do the next one, pause the video, get to the answer, and then once you get to an answer, check your answer with mine. I also want you to answer question number 2 before you see what the answer actually is. So go ahead and do that. All right, so let's see. Hopefully you've got the correct answer. Let's see. The radius in this case is not 10, it's 5, because I gave you the diameter. So it would be 2 pi radius height, 5, 5, plus 2 pi, 5 squared. 5 squared is 25. 5 times 5 is 25. Double that's 50. 2 times 25 is 50. 50 plus 50 is 100. This would be 100 times 3.14. Okay, so hopefully you got 314 centimeters squared. All right, once again, if you need to rewind the video, look at the calculations again. Okay. All we have left now is to do some on your own. So questions, the next 3 questions on the Google Forms refer to the left, middle, and right of box number 5. That's what you see before you. Go ahead and do all of those calculations. Type your answer into Google Forms, and then come back here and get your answers and check your work. Okay, let's check your answers. For the first one, the radius is 6, the height is 8. Here are the calculations. You should have gotten approximately 528 square meters. For the middle one, once again, I didn't give you a radius, I gave you a diameter. The radius is 8. So here are the numbers plugged in correctly, and here is your answer, 603 square feet. And for the last one, I did it again, I gave you a diameter. The radius is 1. Here are the calculations. Here is the answer. Okay. If you need to pause the video, rewind it, check your work, please do that at this time. The only thing we have left for today is just a quick review. The homework will include both rectangular and triangular prisms as well too. So I want to do a quick review to end this video on triangular and rectangular prisms. Recall, there is the formula for rectangular prisms, and there is the formula for triangular prisms. Okay, so last thing is I've given you 2 rectangular prisms and 1 triangular prisms. Once again, do all 3 of these. Type in your answers into the Google Forms. You'll see the question states for the left, the middle, and the right prisms. And then pause the video, obviously, while you're doing this, and then come back and check your answers to mine. Okay, let's check our answers. For the first rectangular prism, now it depends upon what you used as your base. For mine, my perimeter, I use the top and the bottom as my base, so that's why those are my numbers. If you use left and right or front and back as your base, you might have slightly different numbers plugged in. However, your answer will still be the same if you did it correctly. Once again, for the middle one, I use the top as my perimeter. If you didn't use the top, your numbers might be slightly different. However, we will still have gotten the same answers. For the last one, everyone had to choose the triangle as your base. Therefore, the perimeters and all the numbers should be in the right locations. The final answer is there. So there's your 3 answers. Hopefully you got them correct. If you had any issues on this video, if you have any questions, make sure you email me them to me. I'll get them back to you as quickly as I can. We can send 40 emails if necessary. I realize this is not the best way to teach a class. However, we're going to get through this week together. I hope you had a good time on this video and you understood what I did. Just remember the cool thing about this is we can always pause and rewind as many times as we want. So this was a quick 15-minute video. Your homework, remember, is located at the bottom of the Google Forms. If you have any questions, make sure you email me. And if not, I'll see you tomorrow.